we are going to be talking about quadratic functions. Now, quadratic functions always look like y equaling x squared. Sometimes it can be written with f of x instead of y, because f of x and y are the same. So we can write it y equaling x squared, or we could say f of x equaling x squared. Whenever you see f of x, it's just a fancy way of writing y. So now let's talk about parts of our quadratic function. This quadratic function is always going to look like this parabola. When you plug in values here for x, they're going to show up here on the graph like this. So if I plug in 0 for x, I'll get a 0 for y. That's why one of my points here is 0, 0. If I plug 1 in for x, my y is 1. That's why I have 1, 1. If I plug 2 in for x, y is going to be 4 because I square the 2. And that's why I'm way up here at 2, 4. So this is a picture of what this quadratic function looks like. When we have quadratic functions, notice that the x is being squared. They always look like this u. Sometimes the u looks like this. Sometimes the u looks like it's upside down. So let's talk about parts of our quadratic function or our parabola. We're going to talk first about the axis of symmetry. The axis of symmetry for a parabola is a vertical line So the axis of symmetry is a vertical line that cuts the parabola into two mirror images. So for this graph, the vertical line that's going to cut this in half is going to be the y-axis. That's what's going to cut my parabola into two mirror images. So right there, my axis of symmetry for this example is x equaling 0. At x equaling 0, that is the y-axis. Now that we have the axis of symmetry, let's talk about the vertex. The vertex is either a maximum point or a minimum point, depending on what kind of parabola that you have. So again, it's the maximum or the minimum point that you have on a parabola. For this parabola here, because it opens up, it's a smiley face parabola, because of that, it has a minimum value. So the vertex here is a minimum, and the vertex would be 0, 0. So for this example, our vertex is 0, 0. Next, we're going to talk about domain. In Chapter 2, we talked about domain. Domain is all of your x values. It also represents your input. What can you put in for x? When we talk about domain in this particular case, we're still referring to our x values. And we're still referring to the input. So what numbers can I input into this equation for x? Well, I can input anything I want. I can input negative 50 if I want to, in for x, and I would still get a value for y. So I can put in any number that I want for my domain. So the domain here we write as negative infinity all the way through positive infinity. This is how we want to write our domain if we're talking about every number that you can think of for x. So that's going to be our domain. When we talk about our range, again, we're talking about the y values. We're also talking about our output. So for this picture, when I put in all my values for my domain, what does my range become? Well, no matter what x I put in, will I ever get a negative number down here? No, my range will never be negative. In other words, if you look at the picture, my lowest point here is 0. My range goes all the way up from there. So my range begins at 0. So we put a closed bracket to tell me that I'm going to include 0. And then my range is going to take every other y value all the way up here to infinity. It's going to include all of those points. So since it includes all the way to infinity, we write that with an open bracket to indicate that we can never get to infinity. So this would be my range for this parabola. Now, we want to also talk about transformations within this parabola. So what can I do to this picture in order to move my parabola up and down, left and right, and then make it fat or skinny? So let's next talk about all of our transformations. We have seen vertex form for a parabola. We just didn't know it. When we have y equaling,